Hello everyone, welcome to one more webinar from Water Services and Technologies. My name is Christian and we'll be talking today about water balance in industrial plants and mining companies and how to monitor the water use in your operations. So let's start with an introduction about the water use. First, I would like to show you, just to remember the water availability in our planet. So from the whole water that we have on planet Earth, only 2.5% is fresh water. And from this fresh water, almost 70%, 68.7%, are frozen in glaciers. 30% is in groundwater, and only 1.2% is surface water, is the water that we can see. Still on water use, we have different classifications on water use. So for example, we have the consumptive use, which represents the water that we remove from the available supplies without returning it to a water resource system. So for example, livestock production, urban water use, irrigation, and industrial water use. And we also have the non-consumptive use, which represents the water that we do not take out of the water of the resource system, of the water of the ecosystem. For example, navigation, fishing, recreation, and dams. And in all these uses, our aim is always to look for the ecological use, to preserve the ecosystems, the rivers, the mangroves, to maintain the ecosystem working without giving any environmental impact on the fauna and flora. So just for an example, I'm going to show you the water use situation in Brazil. A little history here. So in 1931, in Brazil, 131,000 liters per second of consumptive use water was used. In 2017, this number jumped to 2.08 million liters per second, and it's expected that in 2030, in Brazil, we're gonna use 2.5 million liters per second. A chart that shows you the history of the evolution of the different water uses. So we can see here that irrigation is responsible for the major water use in Brazil, followed by urban and industry. Mining represents by itself an important role on the water use in Brazil, and it's actually the 7th major water use in the country. So this is the situation for 2017. So you can see here that irrigation is the major water use in Brazil, and followed by urban use and industry. And here you have the mining industry. And this chart here shows you how much water is taken out of the ecosystem, for example, from a river, how much water is consumed and how much water returns to the environment. So you can see here that almost more than half of the water taken from irrigation is consumed, and less than 30% of the water returns to the environment. As for urban use, almost 80% of the water returns to the environment. And we can see here in the mining industry that only 30% of the water is consumed, and we have 70% of the water returning to the environment. So we can see that here that most of the water that is taken from rivers or groundwater, it's not consumed inside the production. The water returns to the environment. So we have some potential water reuse here that we could use on our production, and that would mean that we could take less water from the environment. So water balance, what is it and why is it important? Water balance is the difference between the flow of water in and out of a system on a given time. If we are talking about water balance, for example, in a mining company or an industry, we cannot only evaluate the water that comes inside the industry and goes out of the industry. We need to look what's inside this black box here. So we need to see what's the water circuit inside my industry. So for example, I have here a random flow chart for a water circuit inside an industry. So we have the raw water pumping that goes to the treatment plant, that goes to industrial use and general consumption. Inside the industry, we can have different uses for the water, and then we have some water that returns to the wastewater treatment plant, and the water goes after the treatment goes back to the environment. So when we look at the whole water circuit here, we can actually see, for example, potential reuse water that we could use reuse inside the industrial system here. We cannot only count the water that comes to the industry and goes out back to the environment. We need to look what's happening inside here to see what we are doing with the water, to check if we have some opportunities for reusing this water. And why is it important? As a regional context, the water balance can provide reliable data for water loss and regulations, and it can guarantee ecological use of water and water access for everyone, and also preserve ecosystems. So, for example, I'm going to show you an overview of Brazil. So here we have the annual precipitation. You can see here that we have a lot of precipitation on the north of Brazil. This is where the Amazon is located. And we have very few precipitation here on the northeast of Brazil. We have some precipitation here on the south and on the central of Brazil. So looking at this map here, we can say that we probably have some water risks on northeast of Brazil because we have very few precipitation. And if we look here at the average water use in Brazil, you can see here that the most dark colors here represent the biggest water use value. So you can see here in the south of Brazil that we have the biggest values. This is for irrigation. We have a lot of irrigation here in the south of Brazil. We don't have a lot of water use here on the northeast of Brazil. And we have some random spots here where you have a lot of water use. This represents the big cities. For example, here is São Paulo, Rio de Janeiro. This is Brasilia, the capital of Brazil. You have Manaus here, which is the capital of the state of Amazon. So you have local important points of water use like inside Brazil. And on this map here, you have the quality and quantity water risk in Brazil. So as we imagined before, in the northeast of Brazil, we have some critical quantity water risk here because we have very few precipitation and we have water use there. So that's why we have this critical quantity of water use. And in the south of Brazil, where we have a lot of irrigation going on, we also have the critical quantity. And for example, here in the north of Brazil, you can see that the situation is satisfactory. It's where we have a lot of precipitation. So if we look here at all the three maps together, you can see here that few precipitation, and we have some water use here, and we have this critical water quantity risk here. And in the south of Brazil, where we have a good quantity of precipitation, but we have a lot of irrigation, so that's why we have here some quantity water risk. And you can see here that, for example, in the region of São Paulo, where we have a lot of industries here, so we have a huge population, so we have a lot of water use here. You can see that the situation is the risk is big here. We have those red dots here, and we have good amount of precipitation here, but we have too much water use. So this shows that it's very important that we take care of the water balance of, we take care of how much water we are using. If the environment can give us the water that we need. So it's always important to know the water balance too, and we can manage, for example, to reuse the water, and that means less water that we have to take off the environment, for example. And this is a map of the whole world. If you want to check like this map here online, you can look for aqueduct tools from the Water Resources Institute. If you type this on Google, you can find this map here. It's an interactive map. You can zoom in, you can zoom out, and see like more local information. You can have more detailed information when you zoom in, and you have information from all over the world. It's a very nice website here. And going back to the importance of the water balance, for major consumers, it's a very important tool to have some sustainability goals. Also for market demands, because we have on each day, we have more and more market demands on sustainability, on water use. So some investors are looking for industries that have good policies on water use, for example. We have cost reductions, because if we reuse the water, we take less water from the environment. We pay less water we pay less to take water from the environment. So that could mean cost reduction. And also from green marketing, because consumers are getting more and more critics on what we buy, for example, in the supermarket. For example, if I'm looking for this specific product and I have two different brands, I'm gonna see, and I know that the brand A has more sustainable practices than brand B. I'm gonna choose brand A. So it's a good thing for the green marketing. If you have sustainability goals, if you show people that you take care of the water, you take care of the environment. And to represent this importance that the market gives to the environment and to the water, you can check the World Business Council for Sustainable Development, WBCSD. They have a website. If you type WBCSD on Google, you go to their website, and you can see that they have a lot of things there on environment and a lot of things on water. This council, we have the biggest companies on our planet have representatives on this council. So we have like all the biggest companies, the richest industries, they support this council here. And for example, if you go to programs and projects, and then on circular water management, you can have some materials, some publications, some articles on water reuse. There's like a video, there's a guideline for water reuse. They have very nice, very good material there on this website. And you can see here on this section here, it's a lot of things about water. So let's talk now about the water balance for mining and industrial users. So for example, I'm gonna show you here a random flow chart from a particular industry. So we would have the raw water pumping that goes to the treatment plant, and this water goes to the industrial use and for general consumption. Inside the industry, we have different uses for the water, and then the wastewater from both go to the wastewater treatment and then back to the environment. So if you want to analyze this water circuit, if we want to know like the water balance of my industry, if I want to see everything that happens with the water, I want to know the quantity of water that goes through each flux of water, I would need to install, for example, some water meters on each of these fluxes, and this would represent a lot of tables with data. So like we would have one table for each hydrometer, and one table, for example, if I have like a whole year of measurement, I would have a huge table for each one of my hydrometer, and this means I would have a lot of data to handle a lot of data to analyze and to put together in one table and to build some charts or indicators. And as long as my industry grows and as long as time passes by, my table gets bigger and bigger, and it's going to get harder and harder to analyze my data if I don't have, for example, a good data management system. So that's why we always encourage people to have all these tables analyzed from a data management software. So for example, here on water services, we use the Hydro GeoAnalyst, the HGA, and this software gives us a lot of advantages, a lot of benefits on analyzing data. For example, this one, on this case that I showed here, just showed you here. Like we have a lot of hydrometers, a lot of tables, and we want to analyze all this data in a faster way. So, for example, with AGA, what are the main advantages? We have with this particular software here, we have database flexibility. So so it doesn't matter on what kind of data we are dealing with. It doesn't matter on the what your industry and how your industry works with water. It doesn't matter on how your data is stored or what are the units that you use for different parameters. The database inside HA is very flexible. It has a integration with Microsoft Office softwares, for example, Power BI and Excel. It's very easy to import new data inside HEA, and it has the advantage that it validates your data before importing into the database, so that avoid duplicate data, for example. The reports that we build, for example, reports on Excel or Power BI, can be updated automatically after new data is imported inside HEA. There's a quality control and assessment of the data. As I just said, HEA has inside of the software has a validation system that validates your data prior to importing into the database, and that avoids duplicate data. And also we can choose some patterns for the data. For example, if I wanna see all my water volume data on liters, and I don't want to see this data in cubic meters, for example, and then I can tell that to HEA, and it will only allow volume data on liters. It won't allow the user to import data on cubic meters, for example. So it's very good to pattern your data and also to validate and avoid duplicate data. Also, it makes it easier to have your indicators, to calculate your indicators, and also to monitor your data, because as I just said, you can have reports that update automatically after each importation of new data, and also allows the identification of critical points with absence of data. So for example, on the example I showed before of the flow chart I showed before, let's say that we didn't have any data measured for the water that was consumed for general consumption, for example. And that on the report that we built for the water balance that is connected with the HA, we would see that automatically. Like we would see that, oh, I don't have data for this specific month on this specific flux. So then we can investigate what happened, or let's say we don't have any data at all. So yeah, that's important. So we know on which points of our water circuit we have to invest money on hydrometers, for example. We can see where we have water loss. We can see we can identify potential improvements on our measurement data, and we can also have some water reuse opportunities. For example, if we know that the water that goes out of the wastewater treatment plant could be good enough for some industrial use. We know the quantity of the volume in the volume of this water. We could identify a good opportunity here to reuse this water before returning it to the environment. Of course, the example I just said here is very simple, but it happens. If once we know all the water circuit inside our plant, the water balance on a flow chart helps us to see these opportunities of water reuse. I'm going to show you now a case study of a water balance on a mining industry that we implemented here on water services. So we use the softwares Hydro GeoAnalyst, the HGA, and Microsoft Excel for the dashboards. All the water uses were identified inside this mining complex. All the existing data were treated, so we had a lot of data on many different tables, different kind of tables, Excel, PDF, email. So we had a lot of the different data, and so we treated all these existing data, so we could import all this data on HGA. Hydraulic parameters were identified for estimation of some fluxes that had no measured data. For example, water that would go inside some water dams and from some small rivers. And on these small rivers, we didn't have any kind of measurements on flow data. On these particular points here, we needed to identify some hydraulic parameters to estimate the quantity of water. So we had the database structured on HGA. So we rearranged all the tables. We gave names to the tables, and we showed HGA the relationships between all these tables. And existing historical data were imported on HGA, and we built some SQL queries to get the data from HGA into Excel. And on this particular case, we used Microsoft Excel, but we could use Power BI, but we used Excel it was a choice from the client. But we could easily use the Power BI too, so it's a matter of choice from the client. So I'm gonna open the report that we made here. So just to show you. So here is the index of the report of the water balance. So if we go to the dashboard, you can see here we have some indicators here. We have some charts. So for example, we have here the raw water that was used in the selected period. We have the ore production. We have the water reuse proportion. So for example, from all this water that was used, 87% of this amount here was reused. So for example, in this mining company here, we have a lot of water reuse, for example. And here we have an indicator of water used per production. So for example, we have here 40 cubic meters of water per ton of our production. Here we have some buttons where the user can select the period where he wants to see data. For example, he can choose a specific month of a specific year, or he can choose different months, different years. So it's free for the user here to select the period that he wants to see the data. And here on the left, we have just for the user information, we have the percentage of available data for each structure of this mining complex. So for example, let's say that on this structure here, on the water treatment plant, let's say we have 10 different water fluxes here, and we have data for all the 10 fluxes. So that's why it has 100% here. If we had, for example, only 8 fluxes with available data, the number here would be 80%. So the available data here shows only the amount of data that we have from each structure. For example, this structure here, we have no data available. So it's good for the user to see where he needs to invest some money on measurement equipments. This chart here shows shows what kind of data that we have. So what this means is that here, for example, on the blue here, it means the automatic measurement data. On yellow, we have the calculated data. On orange, we have the estimated data. So it shows the liability. It shows if the data is reliable or not. So if we have automatic measure data, it's more trustful data than estimated data, for example. And here we have precipitation and evaporation data for the selected period. So if I choose like the whole year, you can see that we had this amount of rain on the whole year, and on a specific month we had this amount of data of rain data. And these charts here, they show informations on water that was taken from the rivers or groundwater, and the amount of water that was reused or recirculated inside the production system. And this chart here shows from the water taken from the environment, how much was from surface water, how much was from groundwater, how much was from rainwater, and how much was recirculated, was reused. So we have a kind of summary here of all the data that we have on our water balance. So if we go back to the index, and then we go to the overall flow chart. So here we have a flow chart of all the structures we have in this mining complex and all the water fluxes, all the water circuit, and like the red lines represent data that are not available. Green line represents data that is available. And so we have here like for all the fluxes, we have the number, the amount of water that was measured on this particular fluxes. And the same here, you can choose the period of data that you want to see. If I want to see the whole year of 2019, and automatically the number pops up here. If I want to see a particular month, I just choose the month and the numbers will be updated here. And for example, if I want to see specifically the flowchart for the tailings dam, I just click here, and here I have the flowchart more detailed for the tailings dam. So I have here all the entries, all the inlets for the tailings dam, and I have here also precipitation information. I have evaporation, and I have all the outlets here. And on the bottom here, we have a summary of these informations. We have the total inlets, total outlets, and we have some charts here that show all the fluxes there. They are here. They are shown here with the volume, total volume here, and also for the outlets here. And if we go back to the flow chart here, and we can go back to the and the same. You can select the period of data you want to see. For example, here is the whole year for 2017, 2018, 2019, a specific month. And if we go back to the index and go back to the overall flow chart, and if we want to see here a different structure, for example, the dike 2. So it's the same as before. All the inlets here is inside the structure, what happens, and all the outlets here. And we also have the charts here. And then we go back to and then we can go back here to the overall flow chart. And if we go back to index, we have the general table, and this table here is very important for the user. So here you have all the stations that with measurements. It has here the structure where this station is located. it shows the volume of this station in the selected period. It shows the percentage of that this volume represents on the total volume. It shows the data type, if it's estimated, if it's calculated, if it's automatic measure data. It shows where the water comes from and where the water goes to. And why is this table so important? For example, if the user wants to see here the data that represents the biggest volumes, so for example, on this particular 4 stations here, they measure like the majority of the water flows inside the mining company. So this one here represents 36% of the water that flows inside the mining industry. This one here shows, this station here shows that 30% of the water that flows inside our mining industry pass through this station here. And here we can see that it's a calculated data. So here the user can see that the data here is not as reliable as this one here, where we have automatic measured data. So the user now, he knows that he has to invest some money on measurement equipment, for example, a hydrometer, so he can have more reliable data on this flux here. That is a very important point where water flows on this particular mining company. And here it's the same. Here you can choose the period if you want to see like the whole year here. And if we go back, you can see that these are the most important stations inside this mining company. And when the user saw this table here, he actually was impressed that on this particular station here, it had like this big amount of water. So, and now he's investing on measurement equipment. So let's go back to our presentation here. So let's talk about the benefits that the mining company gained after the implementation of the solution using HGA with Microsoft Excel. So now the user can have a global and detailed overview of the water use inside the mining company and inside each of the structure of this mining complex. It has the legacy of the information. So for example, if this mining company has one person that is responsible to analyze all the data, all the water use data inside the mining company. If this mining company doesn't have a data management system, this particular person would have all the data stored in many Excel tables inside some folders of this person's computer. And let's say this person is retiring, and tomorrow he's not gonna show up on the mining company anymore. And the person who's gonna take care of this data now, he has to know where this data is, how all the data was analyzed, and if these tables are inside some random folders of this person that retired, the data can be lost, the information can be lost, and once the company has a data management system, the legacy of the information is guaranteed. So it doesn't matter if a person retires today, the next person that's going to take care of the data, he's going to know that where the data is and how the data was analyzed, and he's going to know that the data is reliable, so he can trust this data because he knows it's inside a database that has validated data. It was also important for the identification of critical points where there were no data measurement. data measured. So you could see on that table there that a lot of the data didn't have any measurement, any data at all. So now the user, now the mining company, is investing money on hydrometers, on equipment to measure the water that flows on each structure of the mining company. Also, it was important for the reliability of the data being analyzed. So now the user is sure that all the data he's looking at, it's reliable data, because the software, HA, has already validated the data before importing into the database. And now the user knows that he's not looking at, for example, some duplicate data or data with a wrong unit, and so he knows what he's looking at. And now the user gets the indicators faster, because now, as you saw there on the dashboard, all he needed to do is to choose the month or the period, the year that he wanted to see the indicators. He just clicked there on the month he wants, and the indicator already shows up on the dashboard. So all he needs to do is to import new data on HA, and the indicator will already be there available on the Excel report. So it's way faster now. And this particular user on this mining company, he told us that before using this report on Excel and HEA, the preparation and analysis of monthly reports used to take 3 or 4 days. He needed to spend these days to analyze all the tables, to put them together, to make the calculations, and then have the indicators and have the charts. And now it takes only a few minutes. It's only the time he needs to import the data on HA, and the data is already there. The indicators and the charts are already there on the report. And also we had this testimonial, very, very nice testimonial from this client. He told us that now he spends less time working on data and more time working on solutions. So that was very nice to hear. And that's the main goal of having HEA and a good report, and you have the water balance with reliable data. That's the main goal. So you can trust the data. You have indicators faster than before. So it was very nice to hear this testimonial. And that's it for today. Thanks a lot, everyone, for joining us. So now let's see the questions that you have here on the chat.